Welcome to this vBrownBag session deploying SQL Server 2019 big data clusters on Kubernetes with Ansible. Today we're going to explore one of the many different ways to deploy a Kubernetes cluster with the end goal of deploying a Kubernetes application, in this case Microsoft SQL Server 2019 big data clusters. My name is Doug Bernhardt. I'm a senior principal engineer with Dell Technologies. I've been at Dell now for a little over 8 years, and I've been working with SQL Server for over 25 years. Storage is obviously a very critical component of a big data or database environment. So now my primary focus is SQL Server and storage integration. While I've managed to hack out what I needed in VMware to get the job done and learned a fair amount about Kubernetes, Ansible, and Linux along the way, my primary background is SQL Server. My journey to Kubernetes and Linux and tools such as Ansible was one of necessity. Since my background is primarily SQL Server, my main goal was to deploy this new application, knowing that I needed a Kubernetes environment, and it was prior to the release of vSphere 7 or even the beta. Therefore, as part of my research and trying to get a Kubernetes environment up and running, I found the method that we're going to cover to be very well suited to my needs. Over the coming days, you'll surely hear a lot about forward-looking concepts and what's new in vSphere 7. This session is not about that. We're going to walk through a basic deployment of Kubernetes that's on a very simple environment of good old ESXi and vCenter. Also, keep in mind that there are literally over 100 different distributions to Kubernetes, as well as various different deployment models. This is a deployment of open source Kubernetes, or what is often referred to as vanilla Kubernetes. To perform the deployment, we're going to use basic VM templates and Ansible open source playbooks. Finally, we will deploy a big data application, Microsoft SQL Server 2019 big data clusters. There are various use cases for this deployment method. Maybe you're not ready to go to 7.0 just yet, or perhaps you want a similar deployment process and tools for bare metal, cloud, and VMs. This deployment method is similar to what you might use to deploy on bare metal with a few virtualization twists. We've got a lot of ground to cover, and this session is a whirlwind tour. If you don't get everything, no worries. I have a link to a paper at the end of the session that covers everything in detail. SQL Server Big Data Clusters is a big data and AI platform that deploys a data lake in a box, as I like to call it, on Kubernetes by running a single deployment command. As part of that deployment, application components including SQL Server instances, Spark, HDFS, and tools such as Grafana and Kibana are all deployed as Kubernetes pods in a single namespace. Since we're working with a data application and containers are ephemeral in nature, the deployment will dynamically provision persistent volumes, somewhere in the range of 28 to 50 or 60, depending on how large you wish to scale the cluster. Because we're working with big data, some or all of these volumes could be several terabytes in size. Knowing Kubernetes is required, I want to use vanilla Kubernetes. I quickly realized I needed to figure out a way to deploy, and this was prior to the latest offerings from VMware. My research quickly led me to different solutions using Ansible. For those of you not familiar with Ansible, a little background. Ansible allows for agentless automation. So you install Ansible, and it allows scripts or collections of scripts organized as playbooks to be run against one or more targets. One of the great things about Ansible is that the scripts are designed to be rerun without harm, if needed, to achieve a desired state. If the target is already in the desired state, then the scripts will simply find nothing to do. There are various modules available for all sorts of operating systems, cloud environments, and hardware platforms, and a very rich library of existing playbooks and samples that can be leveraged. In my case, I was able to find a couple of open source playbooks to accomplish what I needed, customize the parameters for my environment, and execute these playbooks for deployment into the Kubernetes environment. So let's take a look at that now. Here are the high-level steps for this process. First, you'll need to install Ansible if you've not already done so. Next, create a template Linux VM to be used as the deployment source for our multi-node cluster. In this example, I'm using RHEL as my OS. The important thing here is to find an OS supported by kubespray, which most Linux distributions are, and then to use an OS that is supported by the application, in this case, SQL Server Big Data Clusters. Also, in the template VM, you may wish to pre-pull packages that will be downloaded, install tools, etc. Next, Kubernetes will be installed using kubespray. Kubespray is a really cool tool because it not only automates the deployment process, but supports a lot of different options such as networking types, cloud providers for storage, Linux distributions and is therefore really customizable by just changing the config parameters. Finally, we can deploy our application, in this case SQL Server 2019 Big Data Clusters. Now that we've covered the steps, let's quickly walk through a demo of this entire process. The first thing that needs to be done is to build a template to use when creating the cluster VMs. This will be used as a consistent starting point for all of the VMs in the Kubernetes cluster. It's a process that most VMware users are familiar with. You create a VM in the state that it will be the starting point for your VMs in the cluster. Then you shut it down and convert it to a template. Some tips for setting up the VM template. If you take away one thing from this session, it should be this. When working with Kubernetes and vSphere, make sure to set the disk enable UUID property to true. The persistent storage driver uses this to identify storage resources, and if this is not set, persistent storage provisioning will not work, and the errors may not be clear as to why. When you're finished with the template configuration, after you shut down the VM, remove the network adapter. The deployment scripts will add it back and configure it, but they may not work properly with an existing network adapter. Since setting the disk UUID property is so important, let's quickly run through how to do that. Select a VM, in this case the one to be used as a template, and go to Edit Settings, VM Options, and then click the Advanced section and choose Edit Configuration. Here, choose Add Configuration Params and enter disk.enable UUID for the name, true for the value, and click OK. Once the template is ready to go, you can deploy the VMs using the VMware Guest Ansible module. First, you'll need to install Ansible if you don't already have it somewhere. It's agentless, so you just install it on a machine that has access to everything you wish to automate. And as I mentioned earlier, Ansible has several modules that know how to communicate with various infrastructure components. Using this module, you can start with an existing playbook or write your own. I happen to find one to start with on GitHub that you can pull down as a starting point and simply customize the parameters, so that's what I'm using here. The way this playbook is written, I have two configuration files, one with the common settings and one with the settings for each VM. In this case, I'm using a file called answerfile.yaml to specify the VMware environment settings, as well as some common VM settings. As you can see, there's a section for my vSphere environment specified, as well as all of the common guest settings. In another file, I specify the settings for each VM I want to deploy. Ansible has a concept of an inventory file, which is a list of items to configure. In this example, the inventory file is called VMs to deploy. In here, I'm specifying that I'm going to build 5 nodes, 1 master and 4 workers, giving each its own name, IP, and notes. Now, running the command Ansible playbook and passing in the inventory file and the playbook name, this will deploy the VMs. Each VM was deployed as a task. The result is listed in the play recap section, where we see that each VM has a status of OK and changed equal to 1, showing that the deployment changes were applied. A properly written Ansible playbook can be rerun without harm. So here you can see where I reran the script and it just simply came back with everything OK and changes equals 0, so no changes were applied. Now that the VMs are deployed, the Kubernetes cluster can be deployed on top. In this example, I'm using kubespray, which you can read more about on the Kubernetes website, and pull the source from the GitHub link listed here as well, but it's the same idea. Pull down a set of playbooks, customize for the environment, and run. The biggest difference here is that since kubespray offers several different options, there are a lot more parameters that can be specified, but it's still fairly straightforward. First, we need to build the inventory file. This is what the inventory file looks like. We're specifying the names of the Kubernetes nodes as well as the connection information. So this file needs to be updated with the info for all the nodes of the cluster. Next, you need to configure the persistent storage, which in this case we're using vSphere data stores. This is all done in the all.yaml file, which you can see here in the center of this file is the cloud provider, and is set to vSphere, as well as the vSphere credentials and parameters. From here, kubespray will deploy and configure the vSphere cloud provider. Note that this example uses the older in-tree cloud provider. vSphere CSI support was added about 3 months ago to kubespray, so you may want to look at using that instead. but for now, this method works just fine. Depending on what other Kubernetes features you want to modify, such as the overlay network, Kubernetes version, etc., these values can be specified in the other configuration files as well. Just look at the documentation to find the location of the feature that you wish to change. Finally, we run the Ansible playbook command above, and it begins deploying the Kubernetes environment. This is a rather lengthy deployment because it does a ton of work. In my environment of 5 nodes, this takes around 15 to 20 minutes for this process to execute. Once the deployment is complete, the Ansible play recap shows all of the changes that were applied. The final step before deploying the application is to create a Kubernetes storage class. This references a storage provider installed with the cluster, and it points to the data store we wish to use as well as the file system. Here's an example of the storage class definition, and it's created using the kubectl command. Now that the cluster configuration is complete, we can deploy our application, in this case, SQL Server 2019 Big Data Clusters. At this point, the hard work is done, and it's just a matter of following the Microsoft documentation on installing BDC. Because the Kubernetes platform abstracts the infrastructure details, the deployment of BDC is pretty much the same process regardless of the Kubernetes environment. To deploy BDC, we install and run the AZ Data utility provided by Microsoft. This will deploy the entire cluster into a namespace consisting of several pods, services, and persistent volumes, which are dynamically created based on the storage class we provided earlier. As the deployment progresses, you will see various progress messages as the various components come online. After all the components are deployed, the cluster deployment will be complete. At this point, the entire deployment is complete and the big data cluster is ready for use. Now you use Azure Data Studio or your tool of choice to connect to the cluster at the cluster endpoint that is provided here during deployment. The call to action from this session: get more familiar with Ansible if you don't already know it. It's a great tool for configuration and deployment and something super handy to have. Also, deploying Kubernetes with kubespray is a great way to learn about all the various components that make up the Kubernetes environment, and it can be used with physical, virtual, and cloud. This is just one of the many different ways to deploy Kubernetes. Each one has its own personality in terms of tools, ecosystem, and integrations. There are full details of today's demo in the Dell EMC paper mentioned here. This paper is on our new Dell EMC PowerStore appliance, but the steps can be applied to almost any VMware environment. Finally, enjoy the rest of the VMworld presentations. There will be lots to come on new Kubernetes features and capabilities in VMware, specifically around vSphere 7.0 features. This concludes this vBrownBag session for today. Thank you very much for attending, and have a great day.